I'm Anil Kumar, and in this video we'll learn how to solve absolute inequality. As always, I've taken a very simple example to illustrate different methods, and then we'll take up some real good test problems to practice. Question here is to solve absolute value of x plus 1 greater than 1. Now let us first understand the absolute function itself. Absolute value of x plus 1, as you know, is always positive, and this could be defined as a piecewise function. We could write this as x plus 1 when x plus 1 is greater than or equal to 0, and negative of x plus 1 when x plus 1 is less than 0. Or I could also write this as x plus 1 when x is greater than or equals to minus 1, and let me open this, minus x minus 1 when x is less than minus 1, correct? So this is 0 at minus 1. On the right side of minus 1 we have to take the positive value. On left side of minus 1 we have to take the negative of inside function. So that is how you define the function itself. Now one of the methods to solve inequalities is using a graph. So what we can do is we can sketch a graph. So let us say that is our x and y coordinates, x-axis along the horizontal, y along the vertical. X plus 1 absolute value. It is going to give us a 0 when x is equals to minus 1. Let us say this. When x is 0, in that case the value is going to be 1, right? So this is 1 for us. Now we can also graph it by making use of the line x plus 1. X plus 1 means y-intercept of 1, slope of 1, right? So positive slope. So basically it is a straight line going like this. Now when we are saying absolute value, the negative portion is flipped, and then you get absolute value function, correct? So that is the absolute value function. As you can see from the definition, we flipped the line which was from minus infinity to minus 1 to get the absolute value of function, correct? Now when I say that we are looking for a solution for this absolute value to be greater than 1, then what we can do is we can actually draw a line which is equal to 1. So this is y equals to 1, correct? When we are saying that the absolute value function has to be greater than 1, we are looking for the portion which is on the right side of 0, and on this point is going to be minus 2. At minus 2 we are going to get 1, right? So at minus 2, and on the left side of minus 2. So the solution is clearly shown here with the help of a graph. You can write down the solution, correct? Absolute value function, which is in green, is greater than 1, which is this dotted line in blue, in the interval from minus infinity to minus 2 and from 0 to infinity, right? So that is one solution. So you could always solve using graph. So this is graphical method, and the solution is x belongs to real numbers where x is less than minus 2 union x is greater than 0. Simple as that. Now this is one method of solving. Second method which we'll discuss is number line. So this will be now method number 2 for us. We did method number 1 using the graph as shown above. On a number line, what we are trying to say here is that, let me sketch this on a number line. We are saying x plus 1, absolute value, should be greater than 1. X plus 1, this inside function is absolute x moved 1 unit to left. That means you are here, right, at minus 1. Now when you are here at minus 1, you want to be away by 1 unit on either side. So 1 unit to the right will be at 0, and 1 unit to the left will be at minus 2. Now what you want from basic definition is you want to be away right from here. So away from here means this. So on a number line from this strategy, you can straight away write down your answer, right? So this indicates that absolute value of x plus 1 is greater than 1. So you're away, right? You see that? And so you get your solution minus infinity to minus 2 union 0 to infinity. Correct? So that becomes another method. By very basic definition of absolute function, we have got it on the number line. Correct? So that is how you could do it. The third method which we are going to discuss now is algebraic method, right? So in algebraic method, what we do here is that we divide the interval into two portions as the definition. So this is algebraic method. Now as we saw, that absolute function can be defined in the interval from minus infinity to minus 2 and from minus 1 and from minus 1 to infinity as x plus 1 in the interval greater than minus 1 minus x minus 1 in the interval less than minus 1. So we can replace this absolute function and solve it algebraically. So now absolute x plus 1 greater than 1 can be written as minus x minus 1 greater than 1 in the interval on the left side of minus 1, correct? And on the right side, it will be written as x plus 1 greater than 1. Solving these two inequalities, we get our solution. Here we get minus x is greater than 1 plus 1. Minus x is greater than 2. Now this is minus. When you multiply by negative, sign also changes, right? So we get x is less than minus 2. X is less than minus 2, both solutions, right? So that is one solution. Second solution will be on this side. X will be greater than 1, plus 1 taken on this side will be minus 1. So x is greater than 0. Now since x greater than 0 is also on the right side of minus 1, that becomes our solution. Since x minus 2 is within our interval minus infinity to minus 1, that is also our solution. So we have two solutions here, that is x is less than minus 2 union x is greater than 0, right? So as you can see, these are three simple methods to use for solving inequalities. At times it will be specified which method to apply, but generally if it is not specified, you can use the method of your choice. I hope this video really helps you to understand the basic concepts about solving absolute inequalities. I'll encourage you to do some of the review questions where we have solved more complicated or challenging questions on absolute functions. Thank you and all the best.